All right, so we're going to finish up with example 6. I couldn't quite fit it in time-wise in the other video, and it needs its own anyway, because this is the toughest type of problem that I've seen IB throw at us. Notice in our binomial expansion, we have an x squared term in the front, and in the back side, this b value is a rational expression with a variable in the bottom. And we want a coefficient of x to the sixth, but because this is squared and this is in the denominator, I can't just assume it's going to be when x to the sixth would show up in a regular expansion if that were an x and this were just a 4. So I have to be careful of that particular scenario. So I'm going to kind of set this up and I'm going to create a system of equations. And I think that is the fastest way to do it. I can talk a little bit at the end of a very longer way to do it, but I'll talk about that in terms of the fastest way to do it. So if I'm trying to find x to the sixth, then as I start this process, I know for sure that I'm going to have 12, but I don't know what this r is. So I'm going to call that b right now. I know it's going to be 12 based on this, and some point along that process, that 0 through 12, I'll end up with the right exponent, the right answer. So what that means is that my a value, which again, this is whole thing is my a value, is x squared. And that has to be raised to some power. And I don't know what that power is either, so I'm going to call that a. And I'm going to switch colors again, and I'm going to come over here, and b is this whole thing. Doesn't matter how gross it is, that's what it is. It is what it is, so I'm going to put it in there. And that is going to be raised to whatever power is down here. So whatever your 12 choose r, this is my r, that's what ends up over here. So what I know automatically, I can jump quickly to say, okay, well, these two always add up to 12. So I can come over here and say, I know for sure that a plus b has to equal 12, no matter what. It's always true. Now I'm going to apply some exponent rules, and that is that these two things can be multiplied, power to a power. So this term is actually the same as x to the 2a. And these can, this b also gets applied to both of these. So really this would become 4 to the b over x to the b. And because I'm interested in x to the sixth, I can now just focus on the x's. So I'm going to kind of just ignore this piece of it right now. And I can write, okay, well, I know that x to the 2a divided by x to the b, again, I'm just putting these two together, has to equal x to the sixth. It has to. When at the end of this expansion, whatever term I'm trying to get to, these two things together have to combine to x to the sixth, which means, again, using an exponent property, because these bases are the same, I'm allowed to subtract exponents. So I now know that 2a minus b has to equal 6. So I've taken the specifics of this term, and it's now in play to where I want to end up. And now I have a system that's actually quite nice as it is, because I've got a plus b and a minus b. So if I just add these two equations together, the b's cancel. I get 3a equals 18. So I now know a is equal to 6. And so that means this would be a 6 up here. And I also know that using this, because this is the little bit shorter equation, if I were to put the a here, b would also have to equal 6. So I know this has to be 6. And so then I know this has to be 6. And I know I've kind of written over top of all of this. And I'm only asking for the coefficient. So now I'm going to focus on what in the heck would be the actual coefficient of this monstrous term here. I'm going to write the whole term first, and then we'll focus on the coefficient. So what I know for sure is I would have 12, choose 6. This is going to be x, and if that's really a 6, that would be x to the 12, which looks like I'm breaking rules. But over here, I'm going to have 4 to the 6th. Come on. And on the bottom, I would have x to the 6th, which means I would have 12, choose 6. And I'm going to pull this 4 to the 6th out, because that's going to be part of my coefficient. And I have x12 over x6, which I know already has to equal x to the 6th, which is what I wanted. There it is. This is my coefficient. And I'm going to pull up a calculator. I've got the calculator. I'm going to put this in. So I know I have to hit math and go over to probability, come down to NCR, choose enter. I should not choose enter. I need to pull my calculator up so I can actually see what I'm doing. Apologies. All right, let's get out of that, and I'm going to come over and I'm going to hit enter, and I've got 12 in there, and I'm going to come over, choose 6, and I want to multiply that by 4 to the 6th power. Hit enter. There's my that's my coefficient, and it's gigantic, and I'm going to try to write it here anyway. And anyway, that went away, and I don't know where that went. Hold on. There it is. As soon as I touch this, it's going to go away. 3784704. That's your coefficient. I did not quite get it written down. And that's part A. Goodness. So if I come to part B, that's example 6. Oh no, that's the right one. And I want to find the constant term. So now I'm going to do something very similar. The constant term, again, is the one where there are no x's, right? That's the one at the very end when there are no x's at all. So these x's and these x's have to cancel. So I can follow a very similar approach that I did a second ago. I'm going to do 12, choose B, same exact idea. I've got x squared, and I'm going to put that, just like I did a minute ago, to the a power, and then I'm going to have 4 over x to the b power. And it doesn't really matter what letters I put up here, but this one just needs to match this one. So if I write over top of that with red, it doesn't work. All right, so what I need to have happen, again, no matter what, these two have to add up to 12. So that's a given. A plus B has to equal 12. And if I do the same thing I did a second ago, I'm going to ignore all this for a second because I'm going to have x to the 2a. It's going to be literally the same thing I was just looking at a minute ago, except for now, if I have no x term, then 2a minus b has to be 0. Because x to the 0 is 1. So same exact setup we did a second ago, but now I want the constant term, so I want no x's. So now the difference of these has to be 0. So again, I'm set up pretty nicely. If I add these together, I get 3a equals 12, and I get a equals 4. And if a is 4, then b has to be 8. So they have to add up to 12. So now I can come back over here, and I can find this. My answer would be 12. Choose 8, and it would be x to the, again, if a is 4, and if I put a 4 up here, I would have x to the 8th, and then this would become times 4 to the 8th over, and if that's an 8, it applies down there, x to the 8th. So you can see, I just wanted to make sure you believe me, these are going to cancel out. So 12, choose 8, 4 to the 8 is my constant term. And I would, again, personally pull this calculator up, and I would hit math. I'd go over here. I'd come down to NCR, and I'm going to put 12. I'm going to come over, choose 8 this time. And again, I'm going to multiply by 4 to the 8th power, because that's what's right here. And that is my constant term. And I would write it down right down here. But I cannot possibly memorize all those digits this morning. So there you go. That is how you do these kind of challenging problems, and I have seen them on the IB exam. So now, as always, it's your turn to attempt the same idea. You've got 6th expansion You've got terms up here, including a 2. So this 2 gets powered up just like the x squared is going to get powered up. You have a minus. So that minus has to come with your b value, and you're trying to figure out when it's x cubed. So you do the same idea about system of equations. So pause this guy, give it a second, and take a look. All right. Hopefully you've been able to try it and see what you get. This is what you should have gotten. So again, using the capital A and B on these two terms, I know that the A and B have to add up to 6 because that's your biggest power. And so this kind of skips some steps in here, but you would have 2A, and this is a B, and same idea that we did before. When you solve for it, your R or B value would end up being 3. And if you, again, this is just asking for the coefficient, so when I do put the 3 in, this also has to be 3. And then all I care about are the terms, the numeric terms, because this is x6, that's over x cubed, so that gets you this. But my numeric terms would be 6 choose 3, 2 to the third, because it's picking that up, negative 3 to the third, because that negative goes with it. And if you punch that in your calculator, you get 4320, negative 4320. All right, that's it. I think that's the last example on all of this binomial stuff. Have a good day.